inductor is an electrical component that has an inductance L and is measured in henries, H. It is composed of a coil of conductive wire, usually copper, which surrounds a core of air or ferromagnetic material. A current is put through the coil, producing a magnetic field. The strength of the flux of this magnetic field is dependent on the strength of the current. A change in this current will vary the magnetic flux, resulting in the generation of an electromotive force, also known as an EMF. This EMF is the force that opposes the change in current and induces the current into the core, hence the term inductor. When current through an inductor rated at 1 Henry of inductance changes at the rate of 1 amp per second, 1 volt of EMF is produced. To change the value of inductance, the number of loops in the coil, the size of each loop, and the material of the core can be changed to achieve this. An inductor is primarily used in analog circuits, and when combined with capacitors, specific signal frequencies can be filtered out or amplified. Another common use for inductors is to have multiple inductors connected to the same core, creating what is known as a transformer. The first coil carries current, which induces an EMF into the core. The core then induces an EMF into one or more other coils connected to the core. A variation in the number of turns will make the transformer either step up or step down the voltage. For example, if you have 100 turns in the first coil and 50 turns in the second coil, the voltage in the second circuit will be halved. If you add a third coil to the core with 200 turns, it will have its voltage doubled, as the number of turns is doubled from the first coil. A unique process that involves induction occurs within one steel wire, the local steelworks where we work, at the head hardening plant. This plant's purpose is to harden the heads of rails to make them able to withstand added stresses such as bends in railroad tracks. This plant has 2 machines, each having 2 induction coils. Induction heating uses a coil with lower voltage but a much higher frequency than normal to get a more rapid change in current. This causes more eddy current than usual, generating a lot more heat in the core of the inductor, or railheads in our case. This process of induction heating heats the heads up to around 1000 degrees Celsius, and the rail moves at a very slow rate of around 11 millimeters per second. This process takes about 40 minutes per rail and increases the rail hardness from 260 HB up to 340 HB. To put the rail hardness into perspective, wood can vary from 1.6 to 7 HB, aluminium is rated at 15 HB, and copper is rated at 35 HB.